This is a very interesting question from number system, which introduces the concept of modular inverse. So, first of all, let's begin with modular inverse before diving into the question. So, modular is essentially, in a way, it's a base system. It's like changing the base. It's like a circle. In a 10 base, 11 is congruent to 1, which is in turn congruent to 21, and so on. So what it means is that in a 10 base, in a base 10 system, dividing by 1 is equivalent to multiplying by 11. Or in general, x b is the modular inverse of a if a into b is congruent to 1 mod n. Now let's begin with the question. So you have a number which leaves the remainder of 4 upon dividing by 7. So it is 7k plus 4, and n is also equal to 11l plus 8. Fair enough. So we can say that 7k plus 4 is congruent to just a minute. Is congruent to 8 mod 11, which basically means that 7k plus 4 or n, when dividing by 11, leaves the remainder 8, and we have substituted the value of n from here. 7k plus 7k is congruent to 4 mod 11. Now when you have a congruent to b mod n, you can simply multiply it by a number c, b mod n, right? But when you're dividing with it, when you want to divide by some value c, it's better to convert it into a multiplication. That is, dividing by c is equal to divide by c is equivalent to multiply by c inverse, where c inverse is the modular inverse of c. So 7 into x, where x is the modular inverse of 7, is congruent to 1 mod 11. If we want to find the modular inverse of 7, the goal here is thus by, say, hit and trial. One way is obviously by hit and trial. So for x is equal to 1, 7x is 7, and it is not true. For 2 you have 14, again does not work. For 3 it's 21, it's 10, modulo 11 is 10, by into 4 it's 28, again does not hold. 5, 35, does not work. 6, again we might, again it's 42. So no, 7 49 does not work. 8 56. Now this works. 7 into 8 is congruent to 1 mod 11. Thus, you have 7k congruent to 4 mod 11. Now, dividing 7k by 7 is equivalent to multiplying 8 to 4. That is, k is congruent to 32 mod 11. Okay, so um okay, so uh, so this is equal to, now 32 is basically what, 22 plus 9. No, it's 22 plus it's 10. It's 10 mod 11. K is congruent to mod 11. Now since we want to find the smallest value of k, so this expression basically means that k minus 10 should be divisible by 11. What should be the value of k? K can be, well, obviously 10. It can be 21. It can be 32 and so on. But since we want the smallest value of k, or the smallest natural number n, thus we take 10. So 7 into 10 plus 4, which is 74. And 74 when dividing by 2 leaves a remainder of 2. 74 congruent to 2 mod 12. Let's do the other way. That is, 11L plus 8 is congruent to 4 mod 7. So 11L is congruent to minus 4 mod 7. Now minus 4 is basically what? It's is basically plus 3. It's minus 4 is congruent to plus 3 mod 7. Thus 11L is congruent to 3 mod 7. Now we want to find the multiplicative, so modular inverse of 11. So 11 into x is congruent to 1 mod 7. By hit and trial, 1, you have 11, does not work. 2, it's 22, and this fits the description. That is, 11 into 2 is congruent to 1 mod 7. So you have L congruent to 6 mod 7. So the smallest value of L is 6. Smallest minimum value of L to satisfy this equation is 6. Thus 11 into 6 plus 8 is n. N is 74. Again, 74 is congruent to 2 mod 12. Hence works both the ways. So this is a typical question, and the emphasis here is on modulo inverse.